Welcome back to the hyperbolic coding chamber. We are back once again to do more LeetCode. Things are progressing well. We're doing like 30 minutes a day. It's okay, I guess, but we shall see if that will give us any meaningful progress. But a little a day goes a long way, and day 200 has proven that. So more to do, but fortunately we have some comments to go through. We have a comment from Jeans0 on no days off too far from home. The grind has no home. True. The grind is in our hearts. Just like the cholesterol from all of the oil we consume. So that is a true statement. So the grind truly has no home. So actually the grind does have a home. The home is the hyperbolic coding chamber, which is a Discord that you should join because we have lots of tips and tricks. And then we also have comment from Thomas Wong Coding, legendary visionary, entrepreneur, part-time author, and professional computer toucher. Also just got a new job, which is a Feel Strong Man. It's keeping us going. I will also be far from home, semicolon, left parenthesis space for my new job. That is a good reason to be far from home. Feels strong, man. Yeah, it doesn't get any better than that. I remember the video we made. It was called Best News All Year, based on Thomas's news, and that's just a Feel Strong, man. And I also didn't know in Australia there wasn't a big tech presence. So the fact that he secured something close to that is pretty close. It's pretty dope. So feel strong. And yeah, I mean, what else can you say about the hyperbolic coding chamber? One could even go as far to say that we did this for Thomas. No, I'm joking. But actually, Thomas helps us out a lot, and actually helped me out with a lot of grinding problems in the beginning because I literally had no idea what I was doing. So I talked to Thomas. He said he won't forget us at the top. So fortunately, if you join the hyperbolic coding chamber, Thomas or I may be able to help you secure a legendary gig. So another reason to join the hyperbolic coding chamber is for those reasons above. And then we have another comment from the Control C Ninja, another visionary entrepreneur, author, part-time gardener, as well as big computer science thinker, top 3 algorithms, and he's not 3 or 2. I was actually talking to the Control C Ninja, and I was thinking there's actually he was doing the USACO bronze questions, which is a set of questions I think for competitive programming in college, I think. I'm not exactly sure, but they're supposed to be like LC easies, but he said they were like closer to LC mediums, which makes sense. I think the general consensus is that non-LC websites are harder than LC. And that seems to be the case. I think one reason that is because they usually don't tell you where the test cases are failing, and that is a really big cheat code. So when you do the USACO bronze questions, you do something, or actually anything, I think Code Chef and Top Coder 2, you put it in some code and you don't actually know why it failed, which is pretty good because now you have to sit there and sift through the problem or your thinking and see what you didn't consider, which is pretty important for working through that maze in your head of how to solve the problem. Because you walk through the maze, you put your palm on the walls of the maze, release some oil. Eventually, some oil starts to pool and you kind of see everywhere you've been. And then that's where you can see where you haven't been. And then pretty much that's when you make progress. But by always seeing which test case exactly kind of messed you up, you can kind of like do a random walk and get to a solution. And that happens a lot of the times when I'm working on these problems, these LC easy problems. I end up reverse engineering the solution from the test cases, which is bad design and bad practice because I actually have to, or maybe who knows, in real life you keep clicking run until you get it right. So it's probably fine. But I think from the overtraining book or the overlearning book, you can get pretty good at something, apparently, if you overlearn. So being able to sift through the problem and solve it without actually knowing the test cases that are wrong can only help you. So I'm thinking we might make a LeetCode extension to hide the failing test cases, and then it shouldn't be too hard because I think you just need permissions to access contents on the page. And then we can just set like visibility to hidden or something like that. And then I'm gonna talk to the CEO of LeetCode, and we'll probably hop in a VC with Elon, and then we'll see if we can get that change rolled out for everyone. But I think that's where we are. And also, we've been having some very good discussion about Velma in the Discord, so if you're interested in that, you should also join. But I think we're going to do, as we promised, a regular 30-minute session. My brain is not sauced, but it's also not complete. So we're gonna try our best. We did calculate amount paid in taxes yesterday. And we did lemonade change as well, which is nothing like coin change. Okay, and this is where we're gonna, and I think, yeah, we're gonna do merge two binary trees, which hopefully shouldn't be too crazy. So you are given two binary trees, root 1 and root 2. Imagine that you put one of them to cover the other. Some nodes of the two trees are overlapped while others are not. We need to merge the two trees into a new binary tree. The merge rule is that if two nodes overlap, then some node values up. If two nodes overlap, then some node values up as the new value of the merge node. Otherwise, the not null node will be used as the node of the new tree. Return the merge tree. The merging process must start at the root nodes of both trees. Okay, so I think we could make this work. I just don't think we could do it in place. So if we imagine us taking one binary tree, us taking another binary tree and overlapping them, we could do a pair of recursive calls in order traversal, and then we'd have access to the nodes at each point. For example, the first call would be with root node 1, root node 2, and then we could have a set of cases and respond accordingly. Maybe the first root value, if both of them exist, then we'll sum them into a new value, and then we'll call the next node to be processed. Actually, the base case could stay the same. If the two nodes exist, then they should be summed together, and then we continue the call. If only one of them exists, then we should replace the not null value with the value. And then when we merge them, we could return the root node as the node which is in place. This is a little ghetto, but we'll try it anyway. It looks like the function merge trees is already in a way that we can reuse the function definition. So we'll just change this to node 1 and node 2, and it shouldn't be too bothered by that. From here, we can say if node 1 and node 2, right? Then we should say node 1.val equals node 1.val plus node 2.val. Right, then we could have another one, else if to simplify the cases, we could say else if neither of them exist, right? We'll do nothing, and then we'll have an else if, right? If node, we can do if not node 1 or not node 2. And this allows to catch the case where one of the two nodes exists. Now, if one of the two nodes exists, so if node 1 exists, right, then the one that exists is node 1, otherwise it's node 2, right? And then we'll say the non-existent if this was C++ or something like that, we could just say the non-existent one is equal to the opposite of exists, and then just set that value, but we don't actually have access to the place where the variable exists. So we need some way to access. I guess we could work from the child. Is this node? Actually, another way we could do this, rather than doing this recursively, if we reset the problem to how it's supposed to be, I think if we turn them both, if we did in-order traversal for both, and whenever the node doesn't exist, we would place null, we could create two arrays that represent the in-order traversal of both binary trees, and then we could just sum values together to fuse them into one. But I guess we'd have to generate another tree from it. So you know what, let's go back to what we were doing originally. Both nodes exist, and instead of operating on the nodes themselves, can place this in here, and for merge trees, it's like root 1 and root 2, and we can treat those as their parents, and the merge function will handle the children. Let's say if root if not root 1, if one of them doesn't exist, then we should return root 1 if root 1 exists, otherwise return root 2. Down here it means they both exist, and we can say root dot 1 dot val plus equal root 2 dot val. Then we can say merge root 1 dot left and root 2 dot left.
Mariana found a new vehicle to love, an electric vehicle, an EV that produces zero tailpipe emissions that contribute to climate change.
Electric vehicles are worth watching, and there's an EV that's right for just about every lifestyle. Head to SeenOnEV.com to learn more.
And then we can return root 1. So given the merge, we'll just treat it piecewise. So we have 1, right? We'll be passing in 3 and 1. So let's say we want to merge the left ones together. Both the left nodes, if both the left nodes exist, then you want to say node 1 dot left dot val plus equals node 2 dot left dot val. And that means one of the two nodes, left children, doesn't exist. If one of them doesn't exist, then we should replace it to do the overlap. So say if in fact, you could probably shorten the whole thing if we did it like this. If node dot left doesn't exist, that's actually the only case. If node dot left doesn't exist, then node 1 dot left can be equal to a new tree node where the val is node 2 dot left. Then I guess we could change everything here to right. And if we do that, I think this could make sense. Now the question would then be, this would just become merge. now we want to merge node 1 dot left and node 2 dot left, as well as this whole thing only works if node 1 and node 2 exists, because we're looking downwards. And then we're missing this works, but I have no idea why this works. Starting at the node up here, if both nodes exist, I'm going to check the left, right? If both nodes left exist, then we're going to add them, right? Otherwise, if one of them doesn't exist, then we're going to replace it. Then we do the same thing for the right-hand side. And then we call merge for that left child and its right child. Apparently it's pretty slow. Maybe you don't need think we can remove this case here. Node 2 dot left. Node 2 dot left dot val. Right, if the left node doesn't exist, it's also possible that neither of them exist. With the case that we removed, we make sure that both nodes, this is redundant right here. We make sure we remove the case where they both don't exist, and then we can access the case in where at least one of them definitely exists. There should be linear time. Or O of the max of M or N, where M is the largest binary tree. T2 equals null, turn T1. Ah, I see. T1 dot left. We always return T1. So merge trees is really used as which node to return. Okay. We have, you are given a positive integer num. You may swap any two digits of num that have the same parity. Both odd digits or both even digits. Return the largest possible value of num after any number of swaps. So you can swap any two odd numbers, any two even numbers. So this reads as a sorting problem where you'd want to load both the odd numbers into an array and even numbers into an array, and then sort them. Once you sort them, you could sort them both in linear time using something like heap sort. And then we just have to figure out which number is, if the first number is even or odd. So to 3 minutes, you could say odds, which would be a number array. String will say if we parse the string as an integer, right, and then mod 2, I might just better say n is equal to parse int. We say if n mod 2 equals 0, right, then we'll say evens dot push n. Otherwise, we'll say odds dot push n, and then we'll say if parse int num dot to string, so 0 mod 2 equals 0, right? Now for the length, or for the number of digits that exist within num.toString I++, you're going to say swap str plus equal next equals evens, right? We'll do evens dot pop, and it might even just be easier to just swap it like a Boolean flag. Is next like this, we'll say it's true, otherwise it's false. Then we'll say if even is next, right, we'll do evens dot pop, otherwise we'll do odds. And if we're using a ternary within a ternary, but if evens.length isn't empty, we're going to do evens.pop. Otherwise, we're going to do odds.pop. Then we can return parse int swapster. Oh, we never sorted the numbers. We're moving from the end, and that means we want to sort in ascending order. Take the string 1, 2, 3, 4. We have 1 and 3, and 2 and 4. Sort them in ascending order. We know that the first character is 3 in the original string, which means odds go first. If that's the case, right, then we should put 3 first, and we pop. When we get an odd, we can put 4. For some reason, oh my god, I forgot to flip the bit. Even is next equals not even is next. I see, so yeah, and this is what I meant about the test cases. Looks like it's not based on flipping the flag. You just say even reuse the code is next if parse int num.toString oh man, the code is all over the place here. Num as string equals num.toString. Nice. Yeah, I couldn't see this problem as I kept seeing this problem as another problem, and it wasn't that problem. So, rip.